Hi class, I'm going to give you a starting point for the calculations for experiment number 10, okay? So for the first thing that you need to calculate that it tells you in the lab manual is delta H of neutralization of your acid and base per mole of salt formed, okay? So a neutralization reaction is when you have an acid and a base, okay, and we get a salt and a water. So a basic one to make water would be, right, hydrogen ions plus hydroxide yields water, H2O. Okay, so that's a basic neutralization reaction. So the molar heat of neutralization, this is the change in enthalpy when 1 mole of water is formed in a neutralization reaction. Okay, so the neutralization reaction that we performed in class was hydrochloric acid plus potassium hydroxide yields potassium chloride, that's our salt, plus water, okay, H2O. Now we can see here this is already balanced, so we don't need to add any molar numbers in front of our constituents here, okay? So first, what we need to find is the number of moles, lowercase n, right? Number of moles is always indicated by lowercase n. So this is going to be the concentration times the volume, right? Because concentration is, in molarity, is moles per liter, and volume, we're going to have to change to liters, okay? So in order, here, let's go back a little bit. So first we can calculate our joules of energy. So joules is a unit to measure energy for the number of moles of water that is produced. But first we need to find the heat released by the reaction. And to find the heat, Q, it's the same as delta H. And to find that, we do M times C times change in temperature, delta T. Okay. So M is going to be the mass of water. And since we did 50 milliliters of hydrochloric acid and 50 milliliters of potassium hydroxide, together that's 100 milliliters total. And for water, since the density of water is 1, our mass of water we can say is 100 grams since we had 100 milliliters total. Okay, so this will be 100 grams. And we're making water and a salt, right? Okay. C is the heat capacity. And again, we're going to say it's the same as water. So 4.14 joules per gram degrees Celsius, okay, times whatever your delta T was. So maybe it's around 6.5 degrees Celsius, whatever yours was. Okay, so you plug in your number there, okay, and we get our Q of, in this case, if we put 6.5 degrees Celsius, of about 2,717 joules. Convert it to kilojoules, you just move the decimal 3 places to the left, so 2.7 kilojoules. Don't forget to convert. So this is the amount of heat released by the reaction, okay? Okay. Now, to find our change our enthalpy, right? We want to do kilojoules divided by number of moles. So that's why we're finding a number of moles here. Okay, so if we go back here, right, concentration is going to be 1 because it was a 1 molar solution. And volume is going to be 50 milliliters, so it's going to be 0.050 liters, right, we need to convert it, equals 0.05 moles. Okay, so now if we just do our kilojoules, 2.7 divided by our number of moles, 0.05, we get about 54.3 kilojoules per mole. Okay, and now for part one, you'll need to get an actual number here, right? Because your number is going to be a little bit different based on whatever your change in temperature was. And you need to compare that to the accepted value. Okay, so there's an accepted value for a strong acid and strong base neutralization reaction. Okay, so compare that. Part two, you're doing delta H of a solution of your salt per mole of salt used. So you're going to do the same thing, but with the numbers that we used for the second part of the reaction that we did, where we added the salt to the water. Okay, so I want you to figure that one out based on what I've told you here. And then for part three, you're going to use Hess's law. Okay, and you're going to find the standard delta HF of potassium chloride from the experimentally determined values, and there are some values given to you in table 6.1 in the lab manual. Okay, so Hess's law basically describes that the energy of reactions can neither be, or energy in general, can neither be created nor destroyed, so it needs to come from somewhere. Okay, I'm going to post a video that I found that I think you'll find helpful for this. But basically, you're going to be adding together the delta H's that you found, and make sure you understand when it should be negative and when it should be positive, right? So the one that we figured out already are 54.3 kilojoules per mole. This is actually going to be negative, so I'm just going to add a negative sign here. Okay, because the temperature increased, so it's exothermic. If it's endothermic, then this would be a positive number. Okay, so our temperature decreased in part two, right? So for part two calculations, that one is going to be a positive number. Okay, so you will figure out all of your delta H's, okay, add and subtract them together, right, to get your delta H of potassium chloride from your salt. Okay, so I want you to work through that one on your own. It's just adding and subtracting, but you'll just need to figure out what to add and what to subtract there. Okay.